All right, I wanted to touch back in just a little bit more on how to set up percent proportions. Remember, this is just using proportions. One box is the line equals line to solve percent problems. Okay, so remember your one boxes, we've used them for other things like ratios. We've used them for conversions, and each one kind of has something a little bit different. For percents, okay, percent means for every 100 because 1 cent, it takes 100 cents to make $1. Have you ever connected that? Okay, so percents are always out of 100. So that fills in the right side. So we always do part over whole, no matter what you're talking about. So you'll have a fraction, and you're going to compare it to try to make an equivalent percent over 100. Okay? All right. And in this case, if I give you a basic problem, like what is 35% of 50? Okay? Your parts and wholes kind of have some keywords that you might see. If you see something is, you're looking at a part. If you're looking at of 50, then you know you're looking at a whole. Okay, you won't always see those in word problems, but it's good to remember. All right, the important parts about this, every time you see a percent problem, there's a percent in the problem anywhere, or it's asking for one, you need to set up a proportion. Okay, it can look like this, or it can look like this. I usually use this one because it's faster to draw, all right? And it's the same thing, part, whole, percent over 100. All right, they're the same thing, literally. It's just pulling it out and putting an equal sign. All right, and you solve it the same. So the things that you will always have, okay, your percent is obviously a percent. Your 100 here will never ever change. For percent problems, you will never put another number down here. It'll always be 100, okay? The percent should be labeled or asked for. The part is just like in a fraction where you have pieces of a whole. That's what you're looking at. And whole is typically the total amount of something, all right? So let's look at an example. All right. Just to reiterate, you will always use part over whole and percent over 100. These are used in every percent problem, percent proportion. Okay, 100 is used in every single one. You will never be missing it. You will need to find x, that you remember we put x on the place that we are solving for. Okay, you will need to find x either as the part, the whole, or the percent. You'll never put an x where 100 goes. Okay, so you'll either need to solve for the part, you'll need to solve for the whole, you'll need to solve for the percent. You'll be given two of them, and then the other is where your x will go. Okay. So, basic example, 5 is 25% of what number? Okay. So I'm going to go ahead and set it up. I split it apart. Okay, I have my part over whole, and I have my percent over 100 goes right there because we always use it. All right. 5 is 25% of what number? Of what number? All right, so I have my keywords here, is and of. My part, if you remember at the top, goes with is. So 5 is the part. And we're finding 5 is 25%, there's our percent, of what number? So if it's 25%, that means it's a piece of it. Okay? Like if I have a cookie over here and I want to know, okay, this 25%, calling it 5, how much is that of this whole piece? Okay? So we're looking for our whole. All right. To solve these, you can use scale factor. I prefer to always cross multiply and divide. Okay. All right, 100 times 5 gives me 500. All right, and I'm going to keep that because your answer to that multiplication problem is what you then divide. And 500 divided by 25. 25 goes into 50 times 50 twice, exactly. And a lot of people wonder if you stop here. No, because in your original number that you're dividing, I still have something that needs to be divided. So I'm still going to drop it. It goes in 0 times, but I still have to have a number over each of these. All right, so now I can be done. So 5 is 25% of 20. All right, and that is reasonable. Especially, let's look at how reasonable that is. So 5/20ths. If 5 was our part and 20 was our whole that we found, okay, let's simplify this fraction down. Let's convert it to a percent ourselves. So 5/20, if I can divide top and bottom both by 5, 5 divided by 5 is 1, 20 divided by 5 is 4, okay? That's 1/4. That's something that we're pretty familiar with. That's like having 1 out of the 4 quarters you need for a dollar. So you can come over here and you can divide 1 divided by 4 to get your decimal. 4 can't go into 1, but it goes into 10 twice. I have 2 left because 10 minus 8 is 2. Drop another 0. 4 goes into 20 exactly 5 times. I'm out of numbers and I'm done. Okay. So I know this is equal to 25 hundredths or 25 cents, just like I said, 1/4. All right. And if we convert that into a percent by moving it to the right, remember, Dr. Pepper, we have a decimal, we want a percent, so we'll go to the right, equals 25%. Okay. This is how we solve it. This is why it's reasonable. You don't have to do this part. I wanted to show you how you could go back and check. Okay, our last piece is a word problem, but it's almost easier to pull out your parts and wholes out of word problems than it is basic questions. Okay, Linda is in a class of 15 boys and 35 girls. 40% of the students, in the class take the bus to school. How many students take the bus to school? Okay, so she's in a class of 15 boys and 35 girls. 40% of the students, of all of the students. So this is looking for a total. And I'm already noticing it doesn't say 40% of the girls or 40% of the boys. It wants to know students regardless of gender. Okay, take the bus. So how many students take the bus to school? Okay. My question is asking for how many students take it to school. So let's see. 15 boys, 35 girls. I already said I need to know how many total students that is. Let me go ahead and set up my proportion like you should do every time. Draw your lines, fill in your 100. I don't know why I put it, well, T, I guess I was thinking total or whole. Okay. So 40%, I see that, I know where to plug it in. And now what do I do with 15 and 35? It says of the students total, okay? How many total students does she have? Well, to figure that out, we just need to add them together. If she has 15 boys and 35 girls, add them up. 15 plus 35 is 50, so she has a total of 50 students. That is a whole, okay? We want to know how, out of that 50, how many students take the bus. That's how you know where your X goes. Okay. Linda is in a class of 15 boys and 35 girls, which means total of 50. All right. We're going to move on and solve. Remember, I like to always cross multiply and divide. Here I have 40 times 50. My zeros times anything is 0. I'm moving over place value, so I have to add a placeholder 0. 5 times 0 is 0. 5 times 4 is 20. All right. So far I have 2,000. And lastly, I need to divide it by what's left, which is 100. Okay, 100 can't go into 2. It can't go into 20, but it can go into 200 twice. So that's where I'll start. Take out those 200. I have nothing, but I still have a number in my original up here. So I still need to use it and drop it. And 100 can't go into it at all. So we're just going to add that 0. And it's done. There's nothing left on bottom, nothing left up here. I'm done. All right. So out of all 50 students, 40% took the bus, and that was 20 students. So 20 is 40% of 50.